Alright, in the previous video, we did a quick overview of polynomials. In this video, we will review another concept, that is zeros of polynomial. So let's consider a simple example. Consider a polynomial p of x given by p of x equals 5x squared minus 4x minus 12. Now, can you tell me what type of a polynomial is this? Since the degree of the polynomial is 2, we can say that this is a quadratic polynomial. Now, can you find the value of this polynomial when x is equal to 1? Simple. You just need to substitute the value of x as 1 in this expression to find the value of p of 1. When you do that, you get the result as minus 11. What does it mean? It means that when x is equal to 1, the value of the polynomial is minus 11. You can even think of p of x as y. That is, when x equal to 1, y is equal to minus 11. Now, this is something that you can plot in a graph paper, right? Now, when you do that, you will get something like this. We will come back to this graph in a while, but let's quickly find out few other values of this polynomial at some other values of x. Let's find the value of polynomial when x is equal to 2. So, here also you just need to substitute x as 2 in this expression. When you do that, you will get the value of p of x at x equal to 2 as 0. Again, think of p of x as y. So, what does that mean? It means that when x is equal to 2, y is equal to 0. Now, this is again something that you can plot in your graph paper. When you do that, it will look something like this. As you plot more and more points, that is, as you find the value of polynomial at more and more values of x, you can actually plot more and more points in this graph. And you can see how the graph is shaping up. Alright, so we will discuss in detail graphing of a polynomial in the next video, but keep these things in your mind as it will make you ready for the next section. But let's come back to this important result. When x is equal to 2, you got the value of this polynomial as 0. Now this is a very important result. What does it mean? The value of x at which p of x becomes 0 is called 0 of a polynomial. So for this expression 5x squared minus 4x minus 12, we say that x is equal to 2 is the 0 of a polynomial. So let me reiterate. The value of x at which p of x becomes 0 is called 0 of a polynomial. 0 of a polynomial is a very important concept. The remaining of the chapter is built on this concept. So make sure that you have a solid understanding of this before you move on to the next section. Let's consider one more simple example. Let's say p of x as a polynomial given by p of x equals 7x minus 12. Now what kind of a polynomial is this? Since the degree of this polynomial is 1, we call it a linear polynomial. Alright, so how will you find the value of this polynomial when x is equal to 1? Simple. You just need to substitute the value of x as 1 in this expression. Now, when you do that, you will get the value of polynomial as minus 5. That is, we say when x equal to 1, p of x equal to minus 5. Similarly, you can find the value of this polynomial at any value of x. You just need to substitute that particular value of x in this expression. Now, the question I really want you to think over is, how do you find 0 of this polynomial? We can of course try out different values of x and see for what values of x we are getting p of x as 0. But that's not a systematic way of finding the 0 of a polynomial. Let's now look at a methodical way of finding the 0 of a polynomial. Now the question really is, at what value of x p of x becomes 0? So let's assume at x equal to k, p of x equal to 0. What does it mean? It means that P of x is equal to k equals P of k is equal to 0. Now what is P of k? Simple. You just need to substitute the value of x as k. When you do that, you will get P of k as 7k minus 12. And we know that this is equal to 0. So 7k minus 12 is equal to 0. Upon solving, we get the value of k as 12 by 7. This means when x is equal to 12 by 7, we get the value of P of x as 0. In other words, 12 by 7 is a 0 of the polynomial 7x minus 12. See how simple and methodical it was? So what did we just do here? All we did here was we equated the polynomial P of x to 0 and then solved for x. The solution that you obtain for x will be the 0 of the polynomial. Now this is how you systematically find 0 of any higher degree polynomial. We will talk about that and more in the next video. Before you move on to the next section, make sure that you clearly understand whatever we discussed in this video. It's very important to understand the meaning of 0 of a polynomial. If you have clearly understood this, you can confidently move on to the next section. In the next section, we will review 0 of a polynomial and try to gain more insights about these by plotting graphs of these polynomials.